Okay, now it gets slightly more complicated with Ripple. Okay, I think I'm going to go over send payments. I don't have trust lines or issuing different types of currency in here. So I'll go over send payments, and then we can go over issuing different types of currency and trust lines and maybe build something.
Okay.
All right, so lesson 4, send payments. For Bitcoin, we use the send to address RPC command, and you just specify a recipient address and the amount of Bitcoins that you want to send. And this will send from your Bitcoin D server's root account, from its root wallet. And
So we should send this.
if there are any in there, they will soon be gone. Oh, great. So, and all it does is return a transaction hash. And so I just ran that using Node.js. Should be here. There we go, pending.
We should not use that hash for accounting.
Should not use the hash for accounting.
Yeah, that's how Mt. Gox lost. That's how a lot of people lost money with transaction malleability. Basically, like, what I would do is, if you're hosting like an online wallet, and I have funds with you, I withdraw money, and I quickly pick up that transaction in the network, modify, add some like random noise onto the end of the transaction, and propagate it, and then so the transaction is still the exact same transaction, but it has a slightly different hash. And so if that gets accepted into a block, and the original one you sent doesn't, then the transaction hash, then the money will still have been sent, but the transaction hash in the network will actually be different. So then if your software goes to automatically check to see if the transactions you've sent were confirmed and accepted, you'll see that they weren't. And so your accounting backend will say, hey, like this transaction never sent, but actually the money did leave your Bitcoin wallet. So clever. The Mt. Gox lost a few hundred Bitcoin at least that way.
They ended up losing a lot more than that because
Yeah,
of sheer
I
stupidity.
think that was
but
probably how they lost some Bitcoin, but I think it was just negligence or something else. No one knows.
I heard that they didn't have source control.
Really?
Like, it was just so terribly bad.
I don't even know. Yeah.
Oh, that's very good to know.
Yeah.
Check your actual balances rather than
Check
checking
the
that
actual, like,
the payments
Yeah.
happened.
They did make some modifications to Bitcoin Core to help make that harder, but yeah.
So this payment is being propagated by the network and validated. It hasn't been validated by any blocks yet, or hasn't made it into a block yet, but it's sending from the Bitcoin D server to my local wallet. And I'm surprised I have that many.
Is the Dogecoin address in here yours?
And now I have a negative balance somehow. Dogecoin address in there is mine.
Okay, so I'm try sending some more.
But it's not, send some to the Dogecoin D server.
Okay.
So,
Run and get address.
yeah, do get address. He's probably doing this.
When you say root account, What do you mean by that?
That means every Bitcoin D,
Uh-huh.
when you install it, it generates a new account, Bitcoin account, and it maintains the secret for that account.
So
No,
it's
it's
like
like
a-
it's a wallet.
It's a hot wallet.
Cold wallet.
It's a hot wallet.
It's a hot wallet.
Yeah.
That you actually use them. Do they use like hot wallet and cold wallet concept, which is only one wallet in Bitcoin?
I think that's more like an architecture design pattern that it's network agnostic. Like,
If you mine, the Bitcoin goes to that address, or not at all.
I think that you specify which address that
Oh, okay.
the reward goes to. I haven't done mining though. So a hot wallet versus cold wallet. One thing I was reading recently is it's really important to, if you have a Bitcoin D or some server that's receiving like API calls, people can see that IP address. You don't want to have your hot wallet on it. You actually want the hot wallet to be isolated in a private sub network, and then so that the internet, no one can reach it, and then have it pull items off of a queue and then sign and send payments from there, so that no one knows what server actually has your secret key. In this case, this Bitcoin D, if it's signing payments, then we probably want it isolated from the internet. We could have one that's just for generating new accounts and receiving payments, and that one could, the pattern I've seen is people have one for receiving payments and generating new addresses, and then all the Bitcoins are immediately sent into like the bank or the cold wallet from there, so that they're not stored there. And then to actually sign payments, it's a separate Bitcoin D that's not connected to the internet in any way.
Well, just maybe there's a layer between that so that that's not visible.
Right. There's a layer between, and it's like a message queue or a database that you use that people can write to it, and then your Bitcoin D will pick things up off of the queue and send them.
You guys see Dogecoin now, 300.
All right. Let's see if we do. What is it? Let's count balances. Hey! All right, thank you.
Yeah.
Thank you. And I think one Dogecoin is now 1/20th of an XRP.
Yeah, I have no idea. Such currency.
So maybe we'll have,
Well balanced.
let's look at our payment history here. All right. And Dogecoin confirmations, by the way, are way faster.
Yeah.
Way faster. It's like a minute or something per
Yeah.
or two. So we already have 4. I think it's enough.
Why is it faster? Is it
Right.
just because there's less traffic?
No, they changed, like when they made Dogecoin,
It's hard
they
to
changed that parameter. They forked Bitcoin, which is like about 10 minutes average, and changed it so that it's like.
What is the downside of that? Security
the downside of
of changing that parameter?
the block time?
Because I can see the benefit of doing that. But what's the
Well,
downside?
one downside is there's slightly more blockchain data because there's all those extra headers.
Okay. Yeah.
All of the blocks ran out faster. So Bitcoin payments aren't actually very cheap. They're like the actual price of a payment is like $30 or
Yeah.
something. It's really high, but it's subsidized by mining, and so miners receive rewards for propagating payments. Whenever they find a new block, they get 25 Bitcoins. It's a big deal. But the number of Bitcoins is going to run out eventually. All 21 million will have been mined. And at that point, miner,
What's
like,
the motivation for mining?
yeah, so now fees have to pay everything. Yeah, transaction fees. And so, interestingly, with Dogecoin, they already mined all of their Dogecoins because the block time was so much smaller, and so
all of the blocks of
yeah, they're already all created, and yeah, so the incentive is strangely changed, and so Dogecoin actually uses Litecoin's network mining to propagate its transactions now. So,
but I think block time doesn't. The time required to have a secure transaction wouldn't change much because, like, with a lower block time, the difficulty to mine is lower. So, Bitcoin has a 10-minute block time, and Dogecoin has a 2-minute block time. But the same computing power, like in theory, if you had the same amount of like miners, the same amount of computing power would be required to like double spend, or because it's easier to mine a Dogecoin block than a Bitcoin block. So it's the same amount of work to mine 5 Dogecoin blocks as it is to mine 1 Bitcoin block. So I would guess to have the same amount of like certainty that your transaction is confirmed, you would need to wait the same amount of time.
yeah, and with the block time, they make the block time like the target is 10 minutes, and so they adjust the difficulty based on the amount of mining power going after it in order to hit that target block time. So if a ton of people are mining, the difficulty will go way up in order to hit the 10-minute block time. All right, great. So we got some Dogecoins. That's nice. Side note about Dogecoins. There's dogechain.info also, in addition to blockchain.info. Right here, Dogechain. And we should be able to look up our payment we just got on dogechain.info.
There's a Dutch version of everything.
What? Come on now.
Block number. The address.
That's it, right? Maybe
Yeah.
transaction
Just
ID?
do the address.
There it is. Great. No. What? Okay. This has only 2 confirmations.
I think that site is behind, because when I sent the transaction, I checked on here and it didn't show up. It took a while.
Okay. So we sent one. Did we send one payment? We sent a Bitcoin payment. We haven't sent yet the Dogecoin one. And I'm going to try that with our RPC interface. So under lessons 4, send payments. Got Dogecoin send to address with our params. Well, apparently I'm really bad at that. Should be able to use Node.js to send the payment. Okay, great. So we send a 1 Dogecoin payment using Node.js, just to review that. It's the same Node.js client. send to address, Dogecoin address, one Dogecoin. And here it is, shows up in my Dogecoin client. It's question mark, meaning it hasn't been confirmed at all. Any questions so far about Bitcoin and Dogecoin sending? Okay, the Ripple sending is slightly more complicated. It involves 2 or 3 steps usually, because Ripple payments can be more complicated than Bitcoin payments. Ripple payments can involve multiple currencies and conversions between those currencies, and it could involve like even a dozen accounts potentially. So let's look at the Ripple code. There's several steps to using the Ripple REST payment endpoint. So first, the actual endpoint we're looking at is accounts/payments. We're going to ultimately submit our payments to that endpoint by posting it. But before we do that, we have to find a path and make sure that it's possible to make a payment, the payment that we want. And so in Ripple, there's a concept of paths, which, here's the API resource for paths. It's from an account, here's my account. I want to get payment paths to the destination account for some amount here. Here's 1 XRP. Does this URL make sense?
Yes.
So from account to destination.
Yes. So, and the Ripple will then calculate all of the possible payments I can make. So,
The thing is that the account can hold any currency to settle the payment.
right. Yeah. My account
Not
has
necessarily
many
so.
currencies. The destination account, I want to receive 1 XRP, but there's probably many ways that I can go about sending you 1 XRP.
Okay.
Okay. And so,
Do you have to have XRP? Or if you only had Brazilian real, can you send XRP?
yes.
Okay.
If there's a market between Brazilian real and XRP.
Mm-hmm.
And though I do need 0.012 XRP to pay the fee. So you always have to have
Something.
some XRP,
But you always have to have at least, yeah.
but that's only, and that amount is destroyed.
Okay.
So if we actually look at, let's just build up the path here. I'll use your account. To your account, and then 1 plus XRP. So the Ripple Payments Pathfind resource, or the paths resource, returns an array of possible payments that I want to make. The first possible payment, and it will try to compute the cheapest paths first. First payment is 1 XRP from my wallet and 1 XRP going into your wallet. That's pretty straightforward. There is no path at all. It's just direct between our 2 accounts. Things get interesting though when I look at the next one. The source amount now from my account, it's going to be this 0.0000444 gold ounces, right? So it's calculated that on the Ripple market, I can sell this many gold ounces for 1 XRP.
Mm-hmm.
And here's the path it's going to take. What that path actually means is that this account here RRH7. This account is buying gold for XRP. They've already put a bid on the market for gold in exchange for XRP, and so they're going to make the conversion happen if I choose that path.
Okay.
Now, next one, here's a Brazilian real. The price is going to be about one real per XRP. Here's another one. This is actually a good price for XRP. 0.5 of 1 cent. And this actually takes several paths, interestingly. So it looks like this 0.5 of 1% is composed of multiple, even smaller bits that people have put in here. So there's a series of paths. I think it looks like 3 possible accounts that will all add up to this 1 XRP. And here Bitcoin, 0.00014 Bitcoins. And that's even a bunch of different tiny bits.
So it starts with the most efficient, kind of just.
Yes,
Okay.
and so it does its very best to be in the right order.
Okay.
And so you can.
Is it always the best path?
It,
Is the first?
yeah. It tries its best.
How much of a liquidity is needed, or how would it impact the pathfinding? That you have to have sufficient markets in between.
Absolutely, yeah. You have to have a market between the currencies you're trying, the pair you're trying to form, or that could actually be, say there wasn't a market between real and yuan, but there's a market between real and Bitcoin, and a market between Bitcoin and dollars, and a market between dollars and yuan. It will traverse that entire chain of payments. Which is probably what's going on here with the Chinese yuan.
So as long as you have one very liquid market, like for example dollar, that what would be the Ripple that
XRP.
actually may have many pairs trading the liquid.
Exactly.
It's just need one any arbitrary currency that's very liquid.
Yes. Yeah.
That's the point of
the
XRP.
point of XRP. We're trying our best to make liquid markets between all the major assets and XRP, so that all you have to do is make one market between your asset and XRP, and then you'll have liquidity to all the other assets. Okay, and so if I actually want to make this payment, in Ripple REST, I have to build a payment, and then I simply just choose one of these payment objects and post it back directly. So I choose which one I want, and then I just post it back. And that's represented here in the send payment function. Or let's see. I choose a payment that I want to make, and I submit it. So the first step is to find the paths, which we just did, and then I choose just the first payment, which is 1 XRP to 1 XRP. I could make it more interesting by choosing the second payment, which I think is going to be gold, right? And then we can actually see that. And then I'll use your address rather than this one I hard coded. Or I can use your address.
Yeah.
What was your name?
Ruben.
Yeah.
Yes.
Yes.
Yeah, that's good.
There we go. Ruben ESC. Okay, so let's make sure that there's a path to you. Yeah, all the same paths, I think, from my account. So the first one is XRP, the second one is gold. So I'm going to here choose the second payment. That's index 1. and I'll send that. You can try it out. Oh, okay, great. I attempted to send the payment, and it came back with an error. Success false. Error missing parameter secret. Submission must have a secret key to sign and submit the payment. So this is different from Bitcoin in that with the Bitcoin RPC or the Bitcoin D server actually has the secret on the server.
Right.
But with the Ripple server, we keep our secret out of the server. And so I actually have to provide the secret in order to sign the payment.
So you didn't send it?
No, I haven't sent it yet because I don't have my secret here. And I'll have to have you guys promise to not memorize my secret. Already. Okay, so I've set this secret key in my environment. I should be able to make the payment now. Boom. Okay, success. So this is the path that it found. It generated a random unique ID to pass into there. And then Ripple REST, when you post a payment, returns a URL that you can use to check the status of that payment. And here it is, the payment. So source amount, it was 0.0000444 ounces of gold at Gold Bullion International from my account. It used this path, and the destination amount was 1 XRP. So we've done a cross-currency payment from XRP, or from gold to XRP. Some things we didn't set. Invoice ID is still not set. Source tag, destination tag. These things we haven't yet set. So we can go ahead.
Partial payment false.
Oh yeah, partial payment false. So I can show you how to do that. Just so you're looking at the source balance changes now. This time there's actually 2 balance changes. One was the fee in XRP, and one was the gold that I sent. And then the destination received just 1 XRP. So let's try to set like the invoice ID and the tags. In order to do that, all we have to do is modify the payment object that we want to submit. And so looking in our Node.js file, this is under lesson 4, ripple.js. We find a path, and then I'm going to get the payment I want to make is this second payment, which is the gold to XRP. And I can add things to it now. So we could say our invoice ID is 98765. Our source tag equals 5555. Our destination tag equals 321. What else do we want to set?
I don't know.
Partial payment. See if we can set this to true. Try to hack someone. Okay, so now I'm setting these items, and I'll post that payment. Oh, silly me.
So when a gateway like SnapSwap is sending you money after a withdrawal, they're sending source tag.
Invalid parameter invoice ID. Oh, man. Oh, it must be a hash 256. What?
Hash of what?
Hash 256 is a data type
Yeah, I mean, but a hash of what?
of anything.
No, I mean, it's a SHA-256 hash, right?
Yeah.
So the
the invoice ID,
It's just a SHA-256 hash.
right, of what? What's
No,
the
it's just
Invoice number.
it's just a SHA-256 hash.
of anything? I mean, you define.
Yeah, like a random number.
Oh, you can choose.
Yeah. Oh, yeah. You choose what it is.
Oh, okay.
But you have to compute it.
We can figure out how to create a SHA-256 hash if you guys want in Node.js.
Should be built into some.
Probably there's
That
NPM
crypto.
module.
It is in the crypto module. So here's a fun aside. Crypto equals require crypto. So Node.js has a standard library for cryptography, and it has create hash, which I'm pretty sure is the one we want.
Pass that message, right?
Yeah. If anyone wants to try to look this up. Ah, there we go. So create hash SHA-256, and then we do dot update some random something, and then dot digest. So this is a Node.js buffer, which is like a byte array. Buffer is really important in Node.js. Oh boy.
Base 64.
I just don't know if this is gonna, yeah.
Oh, it says Bass 264. not big.
Bass. There we go.
There we go.
That's still not a valid hash 256. Cause it's
What update?
right, cause it's hex.
There we go.
Yeah.
So buffer is a byte array, and so those are just hex representations.
Yeah, this is the. Yeah, the actual hash is a byte array, and then it's converted to hex. And this is a 64 byte. No, 32 byte hex.
Slow. Why is it slow buffer? What is that?
I don't know what slow buffer is. I'll be totally honest. So we'll see if this works. It seems like a long invoice ID, doesn't it? If not, maybe we just won't be able to use invoice ID. Oh, all right, cool. I'm surprised.
Oh, it's very
Okay, so we got our source tag now. So the source tag might mean you are a bank and you have 100,000 customers, and you're trying to send a Ripple payment from one of their accounts. Their account ID might be 5555. So
Like a withdrawal in Snapshot.
yeah, like a withdrawal from SnapSwap. And then destination tag, that might be another user's bank account at a different bank. And so you're really just sending a payment between the two banks, but it gets debited from one account at that bank and credited to another one. That the crediting account is 321. And then we've included our invoice ID, so the two people sending and receiving the payment know which payment it's supposed to represent. And partial payment, true. should we try to make a partial payment, or is that
Yes.
Well, let's try it.
is that enough? Interesting?
What happened? I mean, so
Try to
so-
just coin. Send.
Okay, in order to actually demonstrate the partial payment, not quite sure how we would do that. Maybe if I try to find a path for like a lot of XRP, though I don't want to send him that much XRP. We'll attack this later. Okay, now that we've basically gone through the payments, like all the way through lesson 4, which is like generating addresses, listing your accounts, your balances, and sending payments. I want to try to maybe build something and have you guys all send payments to each other and get each other's accounts and try to use the Ripple, Pathfind, and payment APIs to send some payments.
Okay.
No problem.